Hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 26th of the December daily LeetCode challenge, and we again have a medium question in front of us. From the last few days, we were having some questions on the topic of trees, and finally now we are going to a different topic. And instead of going for the graphs, now LeetCode has decided to go for the DP questions. Okay, these are questions which are related to dynamic programming. You can also call them like DP with memoization. That is, we are doing a question and then we are doing the DP. Okay, so that is the topic, and this is the first question on that topic. So let us quickly begin with this question. It is question 494, target sum. Okay, it's very simple question, very short question. Let's see what it is. You are given an integer array nums and integer target. So you can see the input basically before going to the actual question. This is the actual input given to you, and this is the target. And if you see the constraints for a minute, you will feel that okay, this is going to be easy question because the length, if you see, is going to be very very small. Okay, you may feel like this is going to be an easy question, I can do it using the brute force itself. Okay, but the the thing here is that even if you do the brute force solution, you will get time limit exceeded here. Okay, because the test cases they have designed in such a way that you will not be able to do that within brute force. Okay, as simple as that. So that's why it's marked as a medium question, not an easy question, right? So you're given, okay, what you have to do is, see, you have to build an expression out of the nums by adding one other symbol, that is plus or minus, before each integer in nums, and then concatenate all the strings. Okay, what they're trying to tell you is that, see, in front of each of them, okay, first of all you have to use all of them, then in front of each of them you have two options. Either you can add a plus sign or add a minus sign. Okay, for example, here they are adding the minus sign in the first one. Okay, this is the first one. Here they are adding a minus sign and so on. Okay, and for others they are adding plus. As you can see here, they are adding plus for the first one, but for the second one they are adding minus. Okay, that's how it is. Okay, then ultimately we have to calculate the value of this expression. Okay, that is, you have to do the real maths and calculate the value of the expression. Then you have to see whether you are able to reach the target or not. Okay, so they are basically trying to ask you, return the number of different expressions that you can build which evaluates to target. Okay, normally what will happen if such a question comes, they will also give you a modulo, that is 10 power 9 plus 7. Okay, this kind of modulo they will give you a prime number through which you will have to divide your answer to get a smaller answer. But here they're not giving that because the length they are given is very small, so the number of possibilities is also going to be smaller. Okay, that's why they have not given that. Okay, maybe that is going to be within the, for example, in the Python, if you see, they're just simply asking to return integer. If I see the Java, in the Java also they expect to return a int. So maybe in the int limit itself that answer will be coming. That's why they have not given the 10 power 9 plus 7 modulo. Okay, so that is one thing that I want to tell you. Fine. So now I think you have understood the question what it is. So in front of each one of them, you will have to substitute a plus or a minus. The idea here is you have to try all the possible cases, and then for each of such cases, you have to see whether after doing the real maths you are able to get the target or not. If you are able to get the target, that means that you have reached one possibility. Okay, so you have to you have to return ultimately what are the different possibilities, that is, what are the different ways to get the target by doing all those maths. Okay, as simple as that. Return the number of different expressions that you can build which evaluates to target. Okay, for example, if you see in the example number one, so all are ones here. Okay, so what you are doing, you can do anything. Okay, that is, for each one of them you have the option to either have them as a positive, that is, either add this particular number to the answer or subtract this particular number to the overall answer. Okay, so you can try all such possibilities, and they are saying that these are the only five possibilities which are ultimately resulting into the target. Okay, so they are saying this five possibilities, you can go through them, but idea is very very simple. See, there are going to be five ones here. Okay, five ones. What you have to do is, if you keep in even one of them as negative, that what will happen is, it one minus one will cancel a plus one. Okay, as similar as that. So only three will be remaining, and three is the target here. Okay, so you will see that in all the answers, one thing that is common is there will be a single minus one. Okay, there will be a single minus one, as simple as that. Okay, there will be single minus one in all of them. Okay, in different portions, obviously. Remember, the portion is also matter here. Okay, see, that doesn't mean that you are having a single one means anywhere else, if also if it happens a single one, you have to count as this first one only. Okay, the idea here is the position will also matter. Okay, if the position is different, then it will be a different answer as such. Okay, it will be a different possibility. Okay, it will be a different expression then. Okay, that's what I want to tell you. So yep, that is the question. You can go through the other examples, they're very very simple, and I've already explained the constraints. Okay, yep, you have to go through these things. If you are coding in Java and Python, I will be basically showing the Java session also, but you have to go through these things before deciding the data type of your code. If you're coding in Java and Java and C++, but in Python you don't have those constraints. So first of all, I will show you the Python solution because it is very easy to look and understand. Then we'll go for the Java solution. Okay, so first of all, what we are doing, first I will explain you why in this kind of questions you can also try to do it using the brute force, but the idea here is your brute force solution will not work. I will tell you why it will not work, but remember, these kind of things only will come to you after you analyze the test case. Okay, as simple as that. So let us see why it won't work. So if, like, just for a, okay, let me zoom in first. So just let us consider the part here. Okay, for example, I am having three ones here, and after that I have some more numbers. I'm not bothered about these numbers, just see these three ones. Okay, so what are the things which are happening? See here, I've created you three cascade, three kind of test cases here. Okay, what are they? Here the minus one is present in the first position, here the minus one is present in the second position, and here the minus one is present in the third position. Okay, so minus one is present in different positions, but if you calculate the sum of all of them, you are basically going to get one here. Okay, this also results into one. The sum of all the numbers, this also results into one, and this also results into one. Okay, so the idea here is, for example, see if I am getting a same value here. If you see the minus one is in different position, but the sum resulting into one only. Okay, so the idea here is, if I know the answer for this, okay, for example, if for one of them I go till the end and calculate the value, that is, see, by the time you come here, okay, by the time you cross this, you are going to get this. Okay, index will be 2 and the sum will be 1. After that, we are going to do some calculations for the remaining values. The idea here is, since all of them are going to generate the same value in these three cases, so whatever calculation that you're doing here will be redundant. Okay, that is, you are again going to do that for each one of them. Okay, for each of these cases, this calculation what I'm currently highlighting will be the same. Okay, so for that reason, we are thinking about why not to consolidate, that is, why not to cache this kind of solutions, so that whenever we reach a case where the index is 2, that is, when we are reaching a when we are reaching index 2 and the sum is already 1, in that case we know what is the answer going to come. Okay, that answer we can simply add to all of them. Okay, let us say example. Let us say I took this one and I went through all of the solutions and let's all the possibilities of the highlighted part, and then I got to know that for this, okay, for index equal to 2 and for sum equal to 1, the answer that I'm getting, that is the number of expressions possible is 3. Okay, for this value the number of expression possible is 3. That means even for this I'm going to get 3, that is 3 expressions, 3 different expressions, and same for this I'm going to get 3 different expressions. Okay, remember, this part is same but these parts are different. Okay, this part is different and this part is again different. Okay, so the idea here is, each one of these will is going to add 3 different expressions to my original answer. Okay, to my actual answer. So each one of this is going to contribute, okay, basically plus 3 to my answer. Okay, as simple as that. Even this is going to contribute a plus 3 to my answer, and even this is going to contribute a plus 3 to my answer. Okay, so what I'm trying to tell you is that if I cache this value, that is, for these two keys, if I know the answer, which is 3, then I will simply see whether the index 2 and the sum is 1. If that is the case, then I know that I don't have to calculate the rest of the expressions. I'm guaranteed that the number that is going to contribute to my answer is 3. So I will simply add 3 and I will proceed. Okay, I will not proceed with this part. I will just proceed with a different key. Okay, so I will stop it here itself. This part I will not execute again. So let me show you how it is done in the answer. So for that, what I'm taking, I am first of all calculating the length of the numbers. I'm creating an answer which is 0. Okay, basically I'm not using answer after that. So let me hide this part because I'm not using this afterward. Okay, fine. Now I'm using a cache. Cache is basically, it will, I'm going to cache a particular key value, and for that I'm going to see, basically cache is a map, right? It's a key value pair. So there will be key and there will be value. I'll show how it works. First of all, I see the function here. This is going to be my function. Okay, as simple as that. Now this is the function call for it. Let's see what we're doing. Okay, this is a function call for it. So in the function, basically I am passing two values, the what is the index and what is the current sum. That is, when I reach this index, what is the sum with me. Okay, as simple as that. I'm creating a non-local answer. Okay, even this is not needed after that because I am not using answer as such. Okay, let me hide this part as well. Fine. Now what I'm doing, see if the index is greater than equal to n. Okay, like, see, first of all, this case will not come, but just for your sake I'm doing it, because if you see below that, I'll be writing if index equal to n. Okay, so in that case also I'm returning. So ideally this case will never be coming, but yeah, just as a safety precaution, if you are developing the solution, and if you have not written that, obviously this makes sense. So that's why I've included this. Okay, you can even remove this if you want. Then what I'm checking, if index equal to value, then we have to, either we have reached a solution or we are going to miss a solution. Okay, so in that case I'm just checking whether the sum is target or not. If the sum equal to target, that means we have reached a valid expression. So I'm returning one. Returning one means one expression is reached, one possible expression is reached. Okay, as simple as that. In all other cases I have written 0. That is, remember, rest of the code will not be executed, but will be returning a value. Okay, if this is not the case, okay, if these two are not the case, only then we will be continuing with this part. Okay, what is this? I'm just checking whether this particular key, okay, this whole thing is a key. Okay, sum comma index is present cache. If it's present cache, simply return the value against this particular key. Okay, as simple as that. We'll come to this later, but for now you can just ignore this part. Okay, then what I'm doing, I'm simply creating a tab equal to 0. Then the value is written by these two function calls, I'm adding it to my temp. Okay, as simple as that. And then I'm just caching the value of the temp, and then I'm returning temp. So let us understand what is happening. So this is going to be the first function call. In this function call, what I'm doing, see here, just compare it with the header. Here I'm getting index comes from as the header. So in the next function call, remember this is a recursive function call. What I'm doing, I am first of all doing an index plus one. That is, I'm now going to the next index. Then in the current sum, I'm doing a minus nums of index. That is the number, the value in the current index. Okay, I'm subtracting that from the sum. In the next call, I'm adding it to the sum. Okay, remember this is where the difference is coming. Here I'm subtracting it from the sum. Here I'm adding it from the sum. Okay. Now in both the cases, this is index plus one and this is also index plus one. Okay, as simple as that. So what this will return means that if I go with a subtraction, that is if the current element, that is the element against the current index, if I'm subtracting from the sum, whether we are able to reach a particular answer or not. Okay, this will return 1 and 0 for that. Okay, as simple as that. And similarly for this, okay, this will return how many such possibilities are there, how many such expressions are there if we are going to add the current index to our sum. Similarly, this will tell me, this function call will tell me how many expressions we are going to get if we subtract the current index from the nums. Okay, as simple as that. This both I'm going to add in my temp. Okay, temp is initialized with 0. The return value of these two are going to be added to the temp. Okay, next, now I know that if the sum and index are same, that is, if sum is this and index is this, then always this many expressions are going to come. Okay, I know that now. So whenever the next time I'm going to get sum and index together, okay, like this I have mentioned, right, whenever I'm going to index equal to 2 or sum equal to 1, I know that the number of possible expressions is going to be 3. Now, just example I'm saying, just example, if the number of possible expressions is going to be 3, that means whenever next time I reach the index equal to 2 and sum equal to 1, I will be returning this directly without doing any other calculations. Okay, this is where it will be helpful. So here I'm going doing the caching part, and then I'm returning the temp. Okay, so the next time whenever we reach these two pairs, what will happen, we will be using this part. Okay, the value will be written here itself. Okay, we will not execute this part again. Remember, we will not execute this part again. Here itself we'll be finishing it off. What is that? If we are checking if sum and index are in cache, what we have to do, simply return the cached value. No need to calculate it again. So this is where the caching, that is the memoization, is going to help you. Okay, this is the part where it is going to help you. Here we are doing the caching, that is after doing the actual calculation for the first time, we are caching the value. So the next time when we are reaching that value, it will be checked here and it will be written from here itself. The cache will be written. We will not do the function calls again. Okay, this is what I wanted to show you. So let me quickly go ahead and run this and show you. So as you can see, like I've already segmented the solution. It is creating all the test cases. Now coming to the Java solution for the same. Okay, see, Java solution, I'm doing the exact same thing. Okay, so but here the idea here is inside the function we cannot have another function in Java. Okay, in Python we did that. In Python, basically, we did this particular function inside the given function, but in Java, we can't do that. Okay. For that reason, what I've done is I'm trying to cache. That is, I'm trying to create a parameter for the class so that what all functions, that is, what all values are needed for the other function, I will be having them here. Okay, as a member of the class. Okay, what I'm doing here. So yeah, the n is needed. N is going to be the length of the nums. Okay, and then I need the target. I need the nums array. Then I need a cache. Okay, what I showed you in the Java, sorry, the Python solution, same cache I need here also. So what I'm going to do, see, this is the original function given to us. Okay, so in this, what we are doing, this dot n is equal to nums dot length. Okay, first thing, this dot target is equal to target, this dot nums equal to nums. Okay, then this dot cache is equal to this. Basically, I'm initializing. Okay, this is the cache you have. I'm initializing. This is just declared here, but here I'm going to initialize it. Okay, this dot cache is equal to new hash map, and then this is the function call. This is the function, first function call. This is a recursive function. Remember that this is going to be a recursive function. And after that, we are just going to return cache dot get the 0 comma 0. That is 0 comma 0. For that, first of all, we are converting to a list. Remember the way I have defined it, the key is going to be a list of integers and the value is going to be integer. Okay, I hope you understand that. But key is going to be a list of integers like this. It will be looking something like this. Okay, 0 comma 0. Okay, as you can see here in Python, the key is going to be a tuple of two values, but here we cannot have a tuple or something like that. For that reason, I have the key is going to be a list of two integers. Okay, as simple as that. For that reason, I'm just passing while I'm doing the creating that's while I'm writing the answer, I'm just doing arrays dot as list 0 comma 0. Okay, a list will be created which have 0 comma 0 values, and that whatever is the value for that, that will be written as the final answer. Okay, this is the function call. Let us see how it works. So it's exactly same. Okay, what I've shown you previously, it's exactly same, but let me just go through it once again. Okay, so here the index is there, here the sum is there. Remember, look, the first thing is that if you see the target is the final sum, right, that we have written here itself. They mentioned as the int. Okay, so initially I thought of taking this as the long value, but yeah, it was not needed. Okay, it was not needed as such. If you're taking that as the long value, remember that part. See one thing, you are going to get list of integers. Okay, so you should not, if you're taking long here, then you will have to make the change here. Okay, because ideally what we thought is, see, this is also int, this also int. Okay, then you can have list of integers. But if you're planning to have something else, okay, let us say this is a float, then you cannot write simply integer here. Remember that part, you cannot write like that. Okay, but in our case we can do that because both of them are integers. So what I'm doing, same thing here. If this is the base condition where I'm stopping the recursion. Okay, same thing. If we have reached the index equal to n, then we'll either we have to return 0 or we have reached the right answer. Okay, if we have reached the right answer, we have to return 1, as simple as that. Next, what we are doing, we are just creating a list. Okay, list, I'm calling it as a key because this is going to be key in my map. Okay, this is going to be key in my map. So what are the list consist now? It's going to consist of index and sum. Okay, if you see, that's why I always show the Python solution first, because it will be, really making sense. Okay, see, this is going to be the key. Okay, here what is the key going to be? It is going to be tuple consisting of sum and the index. Okay, the same thing here. The order is different, like I'm writing index first and then I'm writing sum, but in the Python solution, I've written the sum first and then the index. Okay, fine. Now I'm just checking whether this key exists. If this key exists, return the value against it. Okay, as simple as that. If this doesn't exist, what you have to do, you have to calculate the new key. I'm doing the same thing. Temp equal to 0. The value returned by this particular thing, I'm adding in the temp. The value returned by this particular recursive call, I'm adding in my temp. Then I'm inserting the key and the value. Okay, cache dot put key and the value. Okay, as simple as that. And then I'm returning it. Okay, so first time we will do these calculations and then we will make an entry in the cache and then we'll return it. So the next time whenever we are coming to that, this particular if condition will take care of everything. Okay, it will check whether this key exists, and if the key exists, they will return the cached value. Because of that, we are reducing the calculations. So yeah, and that was the question for today. And yeah, this constraint gives you a idea that it's going to be easy thing you can do with brute force, but that is not the case. So yeah, and that was all for this question. If you see the submission rate, it's going to be less than 50%, which is really a shock to me because this question was slightly on the easier side. Okay, you can just simply do some caching and you can get the answer. But I'm really shocked to see that even less than 50% of the people were able to do it. So yeah, and that was all for this question. If you like my efforts, if you like my solutions, please do subscribe to the channel. It really takes a lot of efforts to create this kind of videos and to give you a very customized, very clear kind of solution. Okay, I will always give this code in the comment section. You can go through them, you can do your research, you can understand more on it, especially the Java code, because Java, the syntax matters a lot. Okay, how to write these things, if you may have the idea, remember in Python you just need the idea to solve it because syntax is very simple. But in Java, along with the idea, you also need the syntax to write the correct solution. Okay, so you can take my solution, learn how, just see them as a sample, how things are getting function, and then start writing your own solution. That is the only idea that I can give you, that is the only advice I can give you. If you like my words, please subscribe. See you tomorrow.